The universe is 13.8 billion years old. It contains at least 2 trillion galaxies. Each galaxy contains hundreds of billions of stars. Most of those stars have planets. The conditions for life are not rare. Scientists estimate there could be billions of Earth-like planets in our galaxy alone. And yet, we have never detected a single signal from another civilization. Not one confirmed contact, not one confirmed transmission, not one confirmed sign of intelligent life beyond our own planet. The universe should be full of voices. Instead, all we hear is silence. In 1950, a physicist named Enrico Fermi was eating lunch with colleagues. They were discussing the possibility of extraterrestrial life, and Fermi asked a simple question. A question so obvious that nobody had really asked it before. He said, "Where is everybody?" That question became known as the Fermi paradox. 75 years later, it remains completely unanswered. And the more we discover about the universe, the more disturbing the silence becomes. To understand why the silence is so strange, you need to understand the scale of what we're dealing with. The universe is vast beyond human comprehension, filled with a seemingly infinite number of stars and potential worlds. For decades, we have been listening, pointing our most sensitive instruments towards the heavens, expecting to hear a whisper, a signal, anything to prove we are not alone. But so far, there has been nothing. This profound quiet is what scientists call the Great Silence. And it stands in stark contrast to what our own logic and calculations tell us should be true. In 1961, at a small conference in Greenbank, West Virginia, a young astronomer named Frank Drake was preparing for the first ever meeting on the search for extraterrestrial intelligence, or SETI. To structure the discussion, he scribbled a formula on a blackboard. Its purpose was to estimate the number of active communicating civilizations in our galaxy. This simple, yet profound framework became known as the Drake equation. It wasn't designed to provide a definitive answer, but to organize our ignorance, breaking down a monumental question into smaller, manageable pieces. It multiplies together a series of factors, each a crucial filter in the cosmic search for others. It starts with the raw material, how many stars form each year in our galaxy. Then it narrows down, what fraction of those stars have planets? From there, it gets more specific. What fraction of those planets could support life, existing in the so-called Goldilocks zone, where conditions are just right? The next steps are even more speculative. What fraction of those habitable planets actually develop life? What fraction of that life becomes intelligent? What fraction of that intelligent life develops technology we could detect, like radio transmissions? And finally, the most uncertain and perhaps most sobering variable: how long those civilizations survive and continue to broadcast their existence into the cosmos. When Drake and his colleagues first ran the numbers in 1961, the estimates were incredibly rough, little more than educated guesses for most of the terms. But even with conservative inputs, the answer was staggering. The equation suggested there should be somewhere between 1,000 and 100,000 communicating civilizations in our galaxy right now. The galaxy, it seemed, should be teeming with life, a bustling metropolis of worlds. Since 1961, our astronomical knowledge has exploded, and almost every factor in that equation has been refined, with the numbers becoming more and more optimistic. We now know that nearly every star has planets, thanks to missions like the Kepler Space Telescope. We know that planets in habitable zones are common. We know that the complex chemistry of life forms spontaneously in the cold vacuum of space. Amino acids, the very foundation of proteins, have been found in meteorites that have crashed to Earth. Water, the solvent for life as we know it, exists throughout our own solar system and likely across the galaxy. The building blocks of life are not rare, they are ubiquitous. And yet the answer to Fermi's question, "Where is everybody?" remains the same. Silence. An unnerving, unbroken quiet from the stars. We live in a galaxy with between 200 and 400 billion stars, each a potential sun for a life-bearing world. The observable universe contains roughly 40 quintillion black holes, remnants of colossal stars that lived and died long ago. And across all of it, across 13.8 billion years of cosmic history, a timescale that dwarfs our own existence, we have found exactly one planet with life. This one, that, is the Fermi paradox. The stark, terrifying contradiction between probability and reality. The numbers say the universe should be crowded with voices. The evidence says it isn't. We are left with a profound mystery, a question that echoes in the great silence. Are we first? Are we rare? Or are we simply and terrifyingly alone? Nobody can explain why. Over the past 75 years, as the silence from the cosmos has deepened, scientists have proposed dozens of solutions to the Fermi paradox. These hypotheses attempt to explain the unnerving quiet, and they generally fall into a few broad categories. Each one offers a potential answer, but as we'll see, none of them are fully satisfying. Each leaves us with more questions than answers. Solution 1. They exist, but they haven't contacted us. This is perhaps the most optimistic and yet frustrating category of answers. It suggests the galaxy is teeming with life, but for a variety of reasons, they remain hidden. Maybe intelligent civilizations are common, but have no interest in broadcasting their presence, viewing it as a colossal waste of energy. Perhaps interstellar communication is considered profoundly dangerous, a cosmic rule that we in our infancy have yet to learn. This is the dark forest hypothesis. To announce your location is to invite your own destruction. Or maybe they've been watching us for a long time, conducting a passive galactic-scale study, and have decided not to make contact, placing us in a cosmic zoo or wildlife preserve. Maybe they simply aren't interested in a civilization as young and primitive as ours. We have only been broadcasting radio waves for about 100 years. In cosmic terms, that's a fraction of a second. To them, we might be no more interesting than an ant colony. Solution 2. The universe is simply too big. The sheer scale of space is a barrier that no technology can easily overcome. The Milky Way is 100,000 light-years across. Even traveling at the speed of light, a physical impossibility for anything with mass. Crossing it takes 100,000 years. Radio signals, while traveling at light speed, weaken across those distances, following the inverse square law. A civilization on the other side of the galaxy, broadcasting at our current power levels, would be completely undetectable to us, lost in the background noise of the cosmos. We might simply not have the technology to hear them yet. Our radio telescopes are like trying to spot a single candle on the surface of the moon. We may be listening, but we're not listening hard enough, or in the right way. Solution 3. They existed, but they're gone. This is a more somber possibility. Maybe civilizations rise, develop technology, and then, through war, environmental collapse, or self-inflicted catastrophe, they inevitably collapse. Maybe there are ruins of 1,000 ancient civilizations spread across the galaxy, silent monuments to failed intelligence. In this scenario, intelligence is a temporary condition, a fleeting spark in the cosmic dark. The civilizations capable of contact no longer exist by the time their signals reach us. Their light-speed messages arriving like ghosts at a party that ended millennia ago. We are hearing only echoes from the dead. Solution 4. We are early. The universe, at 13.8 billion years old, feels ancient to us, but it is still young. Star formation is ongoing. The heavy elements necessary for life, forged in the hearts of earlier stars, have only recently become widespread. Maybe most of the life in the universe hasn't evolved yet. Perhaps the conditions for stable, intelligent life are only just now becoming common. In this view, we are not the last inheritors of a long legacy. We are among the first intelligent species to exist. Not the last, the first. The pioneers in a galaxy that will one day be full of life. The silence isn't an absence, it's just the quiet before the dawn. And then there is Solution 5, the one that reframes the entire paradox, the one that changes how you think about everything. It takes the silence from a cosmic mystery and turns it into a personal threat, the one that makes the silence feel personal, the Great Filter. The universe is vast and ancient. With hundreds of billions of galaxies, each containing hundreds of billions of stars, there should be life everywhere. Civilizations should be common. So, where is everybody? This is the Fermi paradox, and it has haunted scientists for decades. In 1998, economist Robin Hanson proposed a chilling potential answer, a theory he called the Great Filter. The idea is this. Somewhere on the long evolutionary path between a lifeless planet and a galaxy-spanning, communicating civilization, there is a barrier. A step in the development of life that is so monumentally difficult, so statistically improbable, or so universally catastrophic that almost nothing makes it through. It acts like a cosmic wall, something that filters out countless potential civilizations before they ever get the chance to become detectable across the stars. The terrifying question for humanity is, where on this timeline is the filter? There are two fundamental possibilities, and the implications of each could not be more different for the future of our species. Possibility 1. The filter is behind us. This is the optimistic view. It suggests that one of the steps we've already taken was the incredibly hard one. Maybe the emergence of life itself, the spark of abiogenesis from non-living matter, was the filter. Or perhaps it was the development of complex eukaryotic cells with a nucleus, a leap that took over 1 billion years on Earth. It could have been the leap from single-celled to multi-celled life, the evolution of photosynthesis, or the development of tool-using abstract intelligence itself. In this scenario, we made it through an impossibly narrow gate. We are one of the rare, perhaps unique species that survived. And the cosmic silence we hear is the sound of an empty galaxy, a frontier waiting for us, because almost nothing else made it this far. If the filter is behind us, the silence is good news. It means we're special, the first to the party. It means we might have a future among the stars. Possibility 2. The filter is ahead of us. This is the deeply pessimistic view. It suggests the hard step is still coming. Maybe every advanced civilization reaches a point where its own technology becomes its executioner. The discovery of nuclear fission inevitably leads to atomic warfare. The mastery of biology leads to an engineered pandemic that can't be contained. Industrial growth leads to irreversible climate collapse. Or perhaps the creation of artificial superintelligence is a universal dead end, a final invention that can't be controlled. In this scenario, maybe every intelligent species eventually creates something that ends it. And the silence is not because we're special. It's the silence of a graveyard, a warning that we haven't reached the filter yet. If the filter is ahead of us, the silence is a profound and terrifying warning. This leads to a strange and counterintuitive conclusion. Robin Hansen wrote something important. He said that, in the search for extraterrestrial life, the most hopeful discovery we could make is nothing. Complete and utter silence. Because the more life we find out there, especially complex life, the more evidence there is that the early steps on the ladder are not the filter. If life is common but technological civilizations are still absent, it logically implies that the filter isn't in the distant past. It must lie in the future, our future. Every fossil of a microbe found on Mars, every discovery of complex organisms on an exoplanet, every confirmed signal from another world, it all just moves the great filter from our past and places it directly in our path. It shortens our odds, suggesting that the doom awaiting us is not only likely, but perhaps inevitable. There is one more theory. It isn't from a scientist. It's from a science fiction novel, and it might be the most unsettling explanation for the silence. In 2008, Chinese author Liu Cixin published a novel called The Dark Forest. In it, he proposed a solution to the Fermi paradox that has since been taken seriously by physicists and philosophers: the dark forest theory. The idea starts with two facts about the universe. First, resources are finite. Second, the intentions of other civilizations can never be fully known. From those two facts, Liu Cixin derives a brutal logic. Every civilization knows that resources run out eventually. Every civilization knows that other civilizations could threaten them. And because you can never fully verify another civilization's intentions, the safest strategy is to eliminate any potential threat before it can act. The universe, under this theory, is like a dark forest. Every civilization is a hunter, moving silently, watching for movement. Because if you make a sound, something might hear you. And in a universe where every civilization is armed and afraid, being heard is being targeted. Under this theory, the silence isn't absence, it's strategy. Every advanced civilization in the universe is hiding, because every civilization that has ever announced itself has been destroyed, and we have been broadcasting our location, our biology, our mathematics, our existence, for 100 years. Enrico Fermi asked his question over lunch in 1950. He didn't expect it to still be unanswered 75 years later. We have now surveyed millions of stars. We have detected thousands of exoplanets. We have found water on moons in our own solar system. We have confirmed that the chemistry of life is common throughout the universe, and we have heard nothing. The silence doesn't prove we're alone. It might prove the opposite. It might mean the universe is crowded with civilizations that have all learned the same lesson. Stay quiet, stay hidden, don't answer. Or it might mean something far simpler, that the step from chemistry to life, or from life to intelligence, or from intelligence to technology, is so improbable that it almost never happens. And we are the result of an accident so unlikely that it borders on miracle. Both answers are terrifying in their own way. One says the universe is full of things that don't want to be found. The other says we are alone in a universe so vast it has no edge. Fermi asked where everyone is. We still don't know. But every year, we listen harder. Every year, the silence grows louder. And every year, the question feels more urgent. Because, whatever the answer is, it tells us something true about the future of this planet, and the kind of future we're capable of having. Stay tuned to the void frequency. The universe has been broadcasting for 13.8 billion years. We're just finally learning to listen.